The first manufactured prototype in engineering is always sloppy, but not in this case. You'll see how SpaceX engineers transformed a spacecraft that appears terribly crude into a much more complex model with smoother metal walls and less obvious welds over time. Compared to the previously produced rough, unsightly surface finishing, the welded connections appear brighter and smoother. So how did the spacecraft go from being a hideous masquerade to having a smooth, well-detailed surface? Welcome to our channel, guys. In today's video, we'll discuss more on SpaceX's huge upgrade to Starship's welding that will blow your mind. Before that, do subscribe to our channel if you haven't already. You'll probably agree that the spacecraft, which stands 390 feet tall with its nose cone pointed upward, is the first structure that appears to be this tall and cylindrical. Did you know welders who worked as reservoir welders in oil corporations and water tanks were the first ones to construct the rough-looking prototypes of starships? These individuals had to be quickly hired by SpaceX to work on the spacecraft. So when it comes to cylindrical skyscraper-like buildings, inexperienced welders created the first Starship prototype. Therefore, they might not have acquired the first-hand experience necessary to operate on such tall, hollow, and wide constructions. But before we go into those details, let's take a look at what is welding and why it is so challenging to do it correctly. Webster's Dictionary describes welding as the use of a hot torch to join two metals together. How did SpaceX accomplish to transform the practice of rough surface welding into something smooth then? To understand this, let's go back in time. The early Starship prototypes were built using a welding method called flux core. In this method, a metal wire is subjected to a voltage that causes an arc to form between the wire and the metal, causing the metal to melt. The metallic wire's tip melts as well, falling into the melted stainless steel to fill up any gaps and cracks that might have been there. Flux core welding involves wrapping the metal wire in a solid substance that, when burned, creates a shielding gas around the weld junction. This protects the weld and keeps it from interacting with nearby oxygen, which might potentially lead to failure. Each ring is made of a single significantly thinner sheet of stainless steel. This kind of thin sheeting will lower the steel's high melting temperature during the welding process. In order to avoid abrupt brittleness during the welding process, the engineers move from stainless steel type 301 to stainless steel type 304L. The welders at SpaceX also upgraded to tip-TIG welding, which gives them more control over the welding arc. Compared to when prior welding techniques were utilized, this allowed the welder to tighten the arc and weld significantly deeper into the metal. SpaceX learned the value of purchasing robotic welding equipment from businesses like Liberty and KUKA. Robotic welding would allow SpaceX to automate the difficult welding process and start making welds that are cleaner and more accurate. For many of the Starship sections, SpaceX has probably turned to laser welding. It is possible to weld the ring segments in a single pass because the heat produced by laser welding is more focused and penetrates the metal to a deeper depth. To increase the strength of each weld, however, a different procedure must be carried out. Once more, before being welded into rings, the stainless steel that Spaceship uses in its construction goes through a procedure known as cold rolling after being cut. So what is cold rolling? Cold rolling is the process of compressing and spreading the metal's grain structure by passing the metal through a set of rollers. This process increases the metal's robustness and durability. Additionally, the heat from the welding process makes the welded section flexible. Therefore, the plashing machine will be put to use by enhancing the strength of all welded seams. The welds are squeezed during the plashing process with a hammer until they have the same hardness as the surrounding metal. Following that, the welds will seem better and the welded seams will have a much smoother appearance. To be clear, the work of SpaceX welders consists solely of applying glass. Although this may not always be the case, for Starship, a good quality for surface finishing is always maintained. This equipment is used to weld, cut, trim, fit, and construct metal components to the prescribed dimensions in order to build and assemble. Engineering drawings and specifications must be analyzed when planning welding operations in a location without procedural knowledge. And to do this, you cannot rely on unskilled laborers who are unable to construct anything out of metal sheets. SpaceX is required to train amateur engineers who are only proficient at welding metal on water or oil tanks and anchor them with advanced level professional welding abilities. The majority of these welders are still employed by SpaceX today on a full-time basis. Now, let's talk about what transpired that initially gave the spacecraft a rough and unattractive appearance. The previous Starship's rough and unattractive appearance was a result of poor fitting and ineffective methods for managing heat intake. If done by hand, pulse MIG should have been used. The best way finally uses robotic pulse TIG or laser, which concentrates the heat and arc for a continuous weld. When done by hand, a welder can go so far before having to change or reposition something on the equipment. Starship is experimenting with a lot of novel, unproven technology at once, despite the fact that SpaceX has a somewhat excellent track record with sketchy prototypes. Well, rocket engineering is challenging. It's appropriate to refer to this attempt as a first-generation rocket. The spacecraft is an experiment in every way. Nothing like this has ever been tried before. It is revolutionary in at least 6 fundamental technologies. SpaceX isn't just creating one spaceship, they're producing 1,000 to 3,000 of them. So, the quick assembly process and the possibility of spreading these procedures out along a manufacturing line are undoubtedly taken into account. And that has significant impact on the Starship's construction materials. The idea of simply mass-producing Starships by rolling the stainless steel into diameter rings and robotically welding the rings together to make long tubes without having to cut or bend the material is quite appealing. We would definitely love to walk you over how things are done in Boca Chica someday. There is in fact a sizable tent where they have repeatedly rolled out stainless steel and a separate area to weld the rings. After electing to use stainless steel, SpaceX began to reap further advantages from the gleaming stainless steel that nature had given them. There's no need to paint it since stainless steel becomes much stronger at cryogenic temperatures, which is great news because liquid oxygen and methane impose enormous pressure on structures when they are kept at ridiculously low temperatures. Additionally, they may friction/stir weld the structure, a skill that robots excel at. This is because the temperature encountered upon re-entry is higher than the steel's melting point. Elon Musk and SpaceX place a high priority on using good, cost-effective materials that enable reuse. If there were a better or less expensive option, SpaceX would have employed it by now. So similar to the case of a commercial aircraft, why not use carbon fiber instead? If carbon fiber is employed by SpaceX and it functions as intended, less fuel would be required to launch the spaceship into orbit as carbon fiber is lighter than steel. So why did SpaceX eventually throw away the carbon fiber to build the spaceship prototype? Let's examine the spacecraft that used carbon fiber in the first case scenario to arrive at this answer. Although the initial BFR idea employed carbon fiber as the fundamental construction material, it was eventually abandoned since it was found that carbon fiber was a poor choice for a vehicle that had to handle temperature extremes ranging from 180 degrees Celsius to 1600 degrees Celsius, especially during re-entries. If you want this composite to survive at high temperatures exceeding 1000 degrees Celsius, you'll need complete insulation and a heat shielding system to take this into account. Stainless steel, on the other hand, is far more tolerant of a wider range of temperatures. It's more robust at cryogenic temperatures and, significantly, retains a significant amount of strength even at temperatures of 1000 degrees Celsius and above. The demand for insulation and a thicker heat shield is greatly reduced as a result. Another crucial factor to take into account is the price difference between stainless steel and carbon fiber, which is to be employed in a system that can be considered more cost-effective. So, using stainless steel comes across as a smart move by SpaceX, and perfecting the welding is only adding to its proficiency. What do you think? Share your thoughts down below, and do not forget to give us a like, share, and do subscribe to our channel for more updates. Thanks for watching.